So here we are given that this boat travels at constant speed 1.50 meter per second inside a marina. Now as it passes through the breakwater, it accelerates at 2.40 meter per second squared. Now we need to calculate two things. In the first part, we have to calculate how fast the boat is moving after accelerating for 5 seconds. And in the B part, we have to find how far the boat has traveled in these 5 seconds. So first we'll study the concept related to this question, and then we'll get back to the question at the end of the video. Welcome to STEM Professionals. In this video we'll discuss three important topics. The first one will be the motion with constant acceleration, and in this we'll derive the equations of motion. The first equation would be velocity as a function of time. The next one would be position as a function of time and velocity. So let's start with the video. So we'll start this video with this topic, that is motion with constant acceleration. And here we'll study the equations that describes the motion of body moving with constant acceleration. And while deriving these equations, we'll assume that there is no drag, or you could say there is no air resistance. So the four equations that will derive will be, the first one will be the velocity as a function of time. The next equation would be position as a function of time and velocity. And the third equation will be position as a function of time and acceleration. This time it's time and acceleration. So we can copy this thing. So this is position as a function of time and acceleration. And the last one will be velocity as a function of position. Now in this video we'll derive only these two equations, this one and this one, and the other two equations will derive in the next video. So we'll start with this one. Now in the earlier videos we studied that average velocity is a ratio of change in velocity divided by the change in time. Now while deriving these equations, we are assuming that the acceleration remains constant. And we know that if acceleration is constant, then average acceleration equals to the instantaneous acceleration. This thing we have studied in the previous videos. So we can write that this is equals to A, and here this A represents the instantaneous acceleration. Now let the final velocity be represented with V, and the initial velocity, let it be V naught, and let initial time Ti to be equals to 0. So at time t equals to 0, the velocity of the particle is v naught, and the final time tf, let it be t. So we can put all these value here. So this would be a is equals to this a I am writing here. Final velocity we have v, initial velocity is v naught, divide by final time is t, and initial time is 0, so this would be t only. Now rearranging the terms, we'll get that v is equals to v naught plus at. Now if you see carefully, this is a straight line on vt graph. Let's try to plot this equation on the vt graph. So this would be the time t, and here this is velocity. So it will be a straight line. Let me show it on the figure, something like that. and this intercept would be v naught, because at time t equals to 0, this is time t equals to 0, so at this time the velocity is v naught, and this is at time t equals to t, the velocity becomes v. So we have represented this equation with a straight line on vt graph. This is v equals to v naught plus at, and this is the first equation that we have derived. Now let's take an example based on this equation. So here in this example we are given that a ball is thrown straight upward with the initial velocity 7.3 meter per second, and the acceleration of the ball is downward with the value 9.81 meter per second squared, and we need to find the velocity after 0.45 second and 0.90 second. So this is the ball which is thrown in the upward direction like this, and the initial velocity we have v naught, that is 7.3 meter per second, and acceleration acts in the downward direction like this with a equals to 9.81 meter per second squared. So we're going to solve the a part first. Now let me show the axis also. This side we are taking the positive axis, and this is the negative side basically. Okay, now since acceleration is constant, so we can use this equation that we have derived earlier, which is v equals to v naught plus at. Now the initial velocity we have 7.3, so we can put it here. This is 7.3 plus, now acceleration is 9.81 negative because it is in the downward direction, so minus 9.81 meter per second squared, and this, the unit is meter per second. Now time we have to take 0.5 seconds because we have to find the velocity of the ball after 0.45 seconds, so time we have to take to be 0.45, so that would be equals to 2.9 meter per second. Therefore the velocity after the time t equals to 0.45 second will be 2.9 meter per second. In a similar fashion, we can calculate the velocity after 0.90 second. Same thing we're going to do, just we can replace this t with 0.90. This would be v equals to v naught is 7.3 plus this is minus 9.81 times this is 0.90. So that would be equals to negative 1.5 meter per second. So this is the answer for the B part. Now here we can conclude one thing, that at this time the velocity of the ball would be in the downward direction because this value comes out to be as negative. Now let's derive the second equation. Now let's try to find that how far a particle can travel in a given time with constant acceleration. Now we'll start with this. Now earlier we have studied this thing, that average velocity is delta x over delta t. Now let the final position xf be represented with x, and initial position of the particle is x naught, and the final time is t, and initial time we are taking to be 0. So we're going to put all these value here. So the average velocity will be equals to xf we have x, xi we have x naught, divide by final time we have t, and initial time we are taking to be 0. So from here rearranging these terms, we'll get x is equals to x naught plus v average times t. Now while deriving these equations we are taking that acceleration is constant. So if you graph the vt graph, if you plot the vt graph for constant acceleration, it will be something like that we have just studied, like this. And here the initial at time t equals to 0, the velocity of the particle is v naught, and here the velocity becomes v. The same graph we have studied just now earlier. Now the average velocity in this case, this would be simply the average of the initial velocity and the final velocity. So initial velocity we have v naught, and final velocity we have v. That would be equals to half of v naught plus v. So you can put this average velocity here. So this x would become x is equals to, let me write it with a different pen. So this x will be equals to x naught as it is, plus this is half v naught plus v times t. So this is the second equation that we have obtained. This is the second equation. And now we can discuss one question based on this equation. So this is the same question that I discussed in the starting of the video. Now let's discuss this question in detail. So initially the boat was traveling at a constant speed of 1.50 meter per second. Now as it passes through the breakwater, it accelerates at 2.40 meter per second squared. So there are two parts. We're going to solve the A part first. So let me first write the input data. The initial velocity for the boat we are given to be, that is v naught is 1.50 meter per second, and the constant acceleration A is given to be 2.40 meter per second squared. So time that we have to take it to be 5 seconds. So after 5 seconds, what will be the velocity? This thing we have to tell. So we can use the first equation that we have obtained, which was v is equals to v naught plus at. So we can put all this value here to find the answer. Initial velocity we have 1.50 meter per second, plus acceleration is 2.40 meter per second squared, times this t. T we have to take to be 5 seconds. So this is 5. Now on further solving, we'll get this value to be equals to 13.5 meter per second. So the answer for the A part is 13.5 meter per second. Now we can solve the second part. Now in the second part, we have to calculate how far has the boat traveled in these 5 seconds. So to solve this, we can use the second equation that we have derived, which was x is equals to x naught plus 1 over 2 v naught plus v times t. Now x naught we have 0, because we are considering our motion from this where x equals to 0. So x naught is 0 plus 1 over 2. Now v naught, the initial velocity at time t equals to 0, we have 1.50 plus the velocity at 5 seconds is 13.5 that we calculated in the A part, multiplied with t is 5. Now we can solve it further to get the answer, and this comes out to be as 37.5 meter. Therefore we can say that the distance traveled by the boat in these 5 seconds will be 37.5 meter. So this is all with this video, and in the next video we'll derive the other two equations of motion that are left. So we'll meet in the next video. Goodbye.